Well, we shouldn't make jokes because that's no good. Okay. 47. Okay, so what is the standard error? Okay, so anytime that's this, you see a question like that, that's what it's asking. So the standard error. Oh yeah. Oh, you know what? Ooh, I made a mistake in the practice final answers. I apologize. Okay, I made a mistake there. All right.
Why? What did you
There
write?
shouldn't be a p hat. There shouldn't be a p hat.
Should be P?
It should be p. Okay. And on the answer sheet. Okay. The standard error is equal to the square root of p times 1 minus p over n. Okay. Not square root of p hat times 1 minus p hat over n. Okay. So I apologize. This is for confidence intervals, and this is for hypothesis tests. Okay, it's written correctly in the study guide. Okay, if you look at the study guide, and it says what is the standard error? Okay, for the test statistic to determine the standard error, it correctly shows p times 1 minus p.
But so for 47, it's only p hat that should be changed to p. Okay, yeah, I get it, yeah.
Yeah, on the practice final, the answer key, use the p.
For test statistic, it should be P. For critical.
For the confidence interval, you use the p hats. Okay. All right. So here we use the p, which is 1/6. Okay. So our standard error is equal to 1/6 times 1 minus 1/6, which is 5/6, over n, which is 100. So this is square root of 0.1667 times 0.8333 over 100. And the answer you get is 0.03727. Okay. So what is our test statistic? We do observed minus null divided by standard error. What did we observe? We observed a p hat of 0.2. Our null hypothesis says 0.1667. And our standard error is 0.03727, okay?
189.
Yeah. Be careful. Do not round too much in this thing, okay? If you do 0.17, okay, your answer will be off by a good amount here, okay? So don't round too much, okay? So I would say don't round
Beyond 4?
too much.
So always have 4 numbers after the decimal.
Yeah, especially for one proportion hypothesis test, it makes a big difference. That's most of the time. If you round, it doesn't make too much of a difference. But for one proportion hypothesis test, rounding makes a big difference. So don't round too much here. All right, and when you do this, you get a test statistic 0.89. All right, so when we look up 0.89, our p-value, okay, so you can either look up 0.89 and then find the tail by doing 1 minus that and doubling it, or you can look up negative 0.89 and find the area in the tail. Okay, so if I look up z equals negative 0.89, then the tail area is equal to 0.1867, and so my p-value is double that, which gives me 0.3734. Okay. If my alpha is 5%, what conclusion do I make? So my p-value is greater than alpha. So do not reject. Don't say accept. Okay. Do not reject the null hypothesis.
So even in the two-sample proportion, you still use the p instead of the p hat for the standard error? Because this is one sample proportion, right?
No, okay. Yeah, for one sample proportion, use this. Okay, use the p. But for two
Oh,
sample
that's a different-
proportions.
That's a different equation.
Yeah, two sample proportion, it's totally different. It's the p hat times 1 minus
But that
p
is
hat.
p hat.
Yeah, that one's p hat, okay. But the p hat there is that combination, total successes over total failures, and things like that, okay? So don't do that, okay? Alright, 49. Okay, so that's it. You, so people ask, how much from chapter 12 do I need to know? Chapter 12, all you need to know is the different sampling methods, okay? There's 4 sampling methods that we talked about. You just got to be able to identify the sampling methods from chapter 12. So chapter 12, know the sampling methods.
Wait.
Hmm?
We still have 49 to 50, right?
Did I skip something?
Yeah.
Yeah, 50 through 58.
40. Wait, didn't we just do 48? I'm confused.
Wait, what
We
about
did
40?
48,
Wait, what
and
about
then
49?
we did 49.
Oh.
49 is do not reject the null hypothesis.
Oh.
Oh, so we just incorporate find the p-value in 49, and so that way.
Yeah.
Okay.
And 50 to 58 is just like a bunch of.
Yeah. So 50 through 52, those are the chapter 12 sampling questions, okay? So let's talk about these. This is the last bit here. Alright, so Major League Baseball wishes to conduct a survey of its players. Instead of trying to create a list of all the players of all their teams, they decide to randomly select 4 of their 30 baseball teams. And they will survey all the players on the 4 selected teams. What kind of sampling is this? This is cluster, right? They're not getting everybody. They're randomly selecting clusters. So this is cluster sampling.
How many options are there?
There's 4. There's simple random sampling, cluster sampling, stratified sampling, and systematic sampling. Okay, so you got to know all 4. 51 says a company wants to survey its employees. The company takes its master list of everyone in the company and randomly selects 100 for the survey. What's this? This is simple random sampling, okay? And you can tell because it says master list of everyone. So it's got a list of everybody, then you can do simple random sampling. If you don't have a list of everyone, it's not going to work. Okay, Toll Bridge wants to survey drivers who use the bridge. Instead of trying to ask all the drivers, they decide to stop every 10th car and ask for their opinions. What sampling is this? Systematic. Anytime you're stopping every 10th or 8th or 50th or whatever, that's systematic when they're going through a line. Okay. So I don't have a stratified example here, but maybe you'll see one on the test. Okay. Yeah, Emmy.
Can you repeat the 52, please?
52? 52 is systematic, okay? So again, the 4 options, okay, so 50, 51 is simple random sampling, and 52 is systematic. Systematic. And not seen, but maybe also there, is stratified.
Can you explain what stratified is again?
Stratified sampling is you know the population has certain proportions. So maybe we know that the population has, this percentage of one race, this percentage of another race, and this percentage of another race, okay? When you select your sample, you make sure your proportions of the sample match the proportions in the population. Yeah.
If you did the same for number 10, the MLB one, if you did that same thing except instead of picking 4 teams, you just split them up by race or weight class. If
Yeah.
you did it that way, that would be stratified, right?
That would be stratified. You say, okay, Major League Baseball knows that 30% of their players are, Latino or something, and you make sure that when you pick your sample, you make sure your sample has 30% Latino, okay? Or something like that. You just make sure the proportions in the population match proportions in the sample. Okay, and then you've got a few kind of random grab bag questions that either relate. So, a bar chart is used for what kind of data? Categorical, okay. But I could ask variations of this question, right? You're not going to see bar chart uses what kind of data on the final. But maybe it'll be, you know, box plot is what for what kind of data? Oh, you tell me. Box plot is numeric. Okay. What about a histogram? Numeric. Okay. 2x2 two-way table or contingency table. Categorical. Okay.
Any
Wait,
tables
say it
are
again?
categorical, right?
A two-way table or contingency table is categorical.
Venn diagram.
Yeah, I don't think we do Venn diagrams. Okay. All right. In a normal model, approximately what proportion are within 2 standard deviations of the mean? 95%. Okay. How much? 68% is within what? 1 standard deviation of the mean. Okay. What about 3 standard deviations? 99.7. Okay.
Wait, within 1 is 60.
Yeah, 68 was 1, 95 within 2, 99.7 within 3, right?
97?
9,
99.7, 99.7. So almost
That's
everybody.
empirical rule, right?
That's the empirical rule.
168.
Yeah. And the intercept in linear regression would be our predicted value when x has what value? When x is 0. When x is 0, that's our predicted value for number 55.
And slope is when y equals 1.
No, slope is how much we expect y to increase for each unit change of x. Every time we increase x by 1, we expect y to change by the amount of the slope. Alright, if the probability of A and B happening together is 0, that means A and B are
Mutually exclusive.
mutually exclusive or
So that's the
disjoint.
same thing as disjoint.
Disjoint, mutually exclusive, same thing. Okay?
But it doesn't mean they're independent, right?
Nope, if they're independent, what's the probability of A and B happening together?
Yeah.
No. If A and B are independent, the probability of A and B happening together is not 0. It's probability of A times the probability of B. If they're independent, probability of A times the probability of B. That's the probability of A and B. Okay. If they're disjoint, can they be independent? Or if they're mutually exclusive, can they be independent? No, absolutely not. If they're mutually exclusive, they are for sure not independent. For a quantitative variable, if there is only one peak in the histogram, how do we describe the shape? Unimodal, right? Okay. If there's 2, it's bimodal, right? What does it mean to be skewed left? Yeah, what does it mean to be skewed left?
Most of your information.
Not normal, not a normal.
Okay, skewed left, the median is bigger than the mean. Okay, skewed left means you've got some points that are way smaller than the average, but you don't have any points that are much bigger than the average, right? Skewed right's just the opposite. You got points that are way larger, but no points that are way smaller, okay? Symmetric means however many you have down here, you've got the same amount up there.
So skewed right is when the median is less than the mean.
Yeah, the mean is greater than the median in skewed right. Yeah. Alright. Which measure of center is not heavily influenced by extreme outliers?
Median.
The median, okay. What else can we say about the median? Yeah,
It's
yeah.
just the position, it's not actually.
Yeah, the median is the middle number. 50% are larger, 50% are smaller. What can we say about the mean? Huh? The mean is the balancing point, influenced by outliers. You take all the points, add them up, divide by n. I don't know. What does a standard deviation measure? Standard deviation measures spread. Okay. What does it mean to have large spread? Hey, we're talking in circles now. Large spread means the numbers are very different from each other. Okay. Small spread means the numbers are very similar to each other. Okay. Can you have a standard deviation for a categorical variable? Standard deviation for a categorical variable.
No.
No, there's no standard deviation for categorical variable, okay? Standard deviation only exists for numeric variables, yeah? That's how we can tell. If we see standard deviation in the problem, we know it's a numeric variable, yeah? Okay. I don't know. Any other questions?
I'm questioning that.
Yeah. Sir?
The last ones, if I study these topics, the last questions, I'll be fine. There's a lot on like the first
okay.
couple of
Topics,
chapters.
right?
Those topics,
Those types of topics,
Like
those
the
types of
different
topics,
graphs,
yeah.
what's
Okay.
standard deviation?
I mean, you know, study topics from regression and correlation. Study topics from, you know, describing distributions and probability. Okay. So I mean, there's only so many topics in the first half of the class. So
How, from chapter 7, 8, and 9, do you estimate maybe?
Like I did.
yeah, 80%.
Like that
80%.
I
Okay.
really did, so we get to the rest.
All right. Good luck, you guys. We'll see you
Thank
guys
you.
next week.